Hi guys, my name is Arushi and today I'm going to be teaching you some of the basics of competition math. I know that many people your age probably do competition math because your parents forced you to, and that is a pretty good reason because parents can be very intimidating sometimes. But actually, competition math is a really cool and very fun experience. It is very engaging and it always keeps you thinking. So I want everyone to just give it an opportunity. So you might be wondering, what's the difference between competition math and regular math which you learn in the classroom? Well, for starters, competition math is mainly word problems and it is a lot more challenging and requires you to apply concepts that you might have learned in regular class in a new and interesting way. Depending on what state you are in, there are many math competitions that you can take. For example, if you're in Missouri, there is something called the Missouri Mathematics League competition, the MCTM, or the CML, which is the Continental Mathematics League competition. Out of all of these, my favorite competition was the CML. I thought that it was the most fun, but the problem types on these competitions are relatively the same. Today we're going to be focusing on the MML. And why the MML, you ask? And that's a good question, and the answer to that question is because on the MML you can get the practice tests for free, and for the rest of them you have to pay, so technically we're only doing it because I'm cheap. But let's get started anyways. A lot of the problems on the MML are actually just long computation problems, which would be way easier if you found a pattern. For example, here is a problem that you might see on the MML. What is the sum of all the numbers from 1 to 10? Well, your first inclination might just be to just add it out. But do you really have all that time? You only have 30 minutes to do 30 questions on the MML, and you want to save all the time you can have for the hard problems. Okay, so now we have all the numbers from 1 to 10 written out. But should we really add them up in order? Or should we try to do something unique? For example, what would happen if I added 1 plus 10? Well, 1 plus 10 equals 11. What would happen if I added 2 plus 9? Now we have 1, 10, 2, and 9 taken care of. This would also be 11. That's interesting. They're both the same. Now we can try the same thing for adding up 3 and 8, which would be 11. 4 and 7, which would also be 11. 5 and 6, which would also be 11. Wow, did you see that coming? So instead of having to add up all of these numbers, we can actually just add up 11 5 times. And what is 11 times 5? 55. So there, we have solved that problem. This is a real question that was on the 2019 MML for 4th graders. It was one of the beginning questions, so it was meant to be easier. 20 minus 18 plus 20 minus 18 plus 20 minus 18 equals. Now, instead of subtracting 18 from 20, then adding 20, then subtracting 18, then adding 20, then subtracting 18, you could notice something simple. 20 minus 18 is 2, plus 20 minus 18, which is still 2, plus 20 minus 18, which is still 2. And all of this is equal to 6. So we basically just took a kind of irritating looking problem and dumbed it down to a couple of easy steps and we got the answer. So basically that's the model I want you to follow for the rest of the problems. Here is a problem that is just a little bit harder. What is the units digit of 12 times 13 times 14? Well, for starters, we do not need to do the entire product. We do not need to find the entire product of this. We can just find 2 times 3 times 4 and have the answer because it's only asking for the units digit. And the units digit does not depend on the tens digit, which happens to be 1 in all of these 3 cases. So the question really comes down to, what is 2 times 3 times 4? 2 times 3 is 6, 6 times 4 is 24. So you have a product of 24, and the unit digit on 24 is 4. So there we go. So there will be many such problems of this difficulty on the first 2 pages of the MML. Basically, you just need to know short, quick ways to do them, and even though they're really short, it's like really helpful to know how to do them fast, because then you have more time left for the harder problems. One of the harder problems is what I'm about to do right now. Here is another question which I think is pretty hard. Like, I probably would not have been able to get this when I was in 4th grade. How many numbers between 100 and 200 are divisible by both 4 and 6? Well, there are a lot of numbers between 100 and 200, so you don't want to write down all the multiples of 4 and all the multiples of 6, because that would obviously take too much time. Instead, let's think of it like this. What does it mean to be divisible by both 4 and 6? Let me give you a number. 24. That's divisible by 4 and 6. So every multiple of 24, like 48 or 72, will also be divisible by 4 and 6, because 24 itself is divisible by 4 and 6. So does this imply that I could just take all the multiples of 24 between 100 and 200, and those would give me the numbers that are divisible by 4 and 6? Well, okay, so we have 120, 144, 168, and 192, all of which are divisible by both 4 and 6. But here's the problem. So I think that we're missing some numbers from this list. Because what about 108? 108 is divisible by 4 and 6, but it is not a multiple of 24, which is why we left it out. There are more such numbers on the list, like 132 and 156, that we just haven't accounted for. Well, what are we doing wrong? I think that I have an idea. Instead of just using any old multiple, let's try to use the least common multiple between 4 and 6. I ran out of tape, so I just got band-aids to put it up there, so yeah. Improvise, adapt, overcome, children. The LCM of 4 and 6 is 12. But why is the LCM more useful than just any old multiple? Well, the thing about the least common multiple is that if a number is divisible by 4 and 6, it has to be divisible by 12. But it does not have to be divisible by 24. So basically, if I just take all the numbers between 100 and 200 that are divisible by 12, it'll be like taking all of the numbers between 100 and 200, which are divisible by 4 and 6. There will not be actually any difference. We will not be missing any numbers out. So let's make a list of all the numbers that are divisible by 12 between 100 and 200. We have 108, 120, 132, 144, 156, 168, 180, 192. This is a total of 8 numbers. So your answer to this question would be 8. So you're going to learn that the concept of using factors and multiples and prime factorization is very important in some of these problems on the MML. So this is question 9 from the 2018 to 2019 4th grade MML. Which of the following is the greatest? 1 times 2 times 12, 2 times 3 times 4, 4 times 2 times 2, or 2 times 4 times 4? Well, the first step is find the prime factorization of these quantities. You might be thinking that I can do this pretty fast on my own, but I think that you could do it faster if you found the prime factorization. For these problems, it's not going to be hard. Like, it's not like they're going to come up with some crazy prime factorization with like 11s or 7s or 19s. All of these are pretty basic. They stay in the 2, 5, 7 kind of range. So like, for example, 2 to the third times 3, 2 to the third times 3, 2 to the fourth, and 2 to the fifth. These are the prime factorizations of all of these numbers. And now the time has come to figure out which one of these is the biggest. Well, 2 to the third times 3 and 2 to the third times 3 are the same. So if you So we know that none of these can be the answer because they're the same. So if one of them were to be the biggest, then the other one would also have to be the biggest, and that just doesn't work out. You can't have two answers. So you're only left with option C and option D. Option C is 2 to the 4th and option D is 2 to the 5th. Well, it should be pretty obvious that multiplying 2 by itself 5 times is more than multiplying 2 by itself 4 times. So the correct answer to this question is D, 2 times 2 times 4 times 4. Okay, this is question 18 from the 2018 to 2019 MML. 2 times 4 times 5 times 25 equals 6 times 125, 6 times 150, 8 times 150, or 10 times 100. Okay, so first of all, how are we going to figure out what this equals in terms of prime factorization? Well, whichever one of these options has the same prime factorization as this is going to be the answer to this question. But do you really want to find the prime factorization of all these long and irritating numbers? No, but do you really want to multiply them out either? Like, do you want to do 6 times 125, then 6 times 150, then 8 times 150? No, you don't want to do either of these things. So right now, I'm giving you two annoying options. Find the prime factorization or multiply them all out. You want to do neither of them. So which one should you do? Well, from experience, I suggest that you try the prime factorization one first, because even though it takes a lot of time, you're going to be able to figure out some interesting patterns which will help you eliminate certain options. For example, I'll just find the prime factorization of that really fast. That would be 2 to the 3rd times 5 to the 3rd. Again, as promised, no big numbers, no 7s, no 11s, no 19s or 23s. It's pretty basic. And then I'm going to start doing it for this one too. Well, here I have 3 times 2 times 5 to the 3rd. That's interesting. I already know that this cannot be equal to that because this has a factor of 3 in it, while this above answer doesn't. So this is divisible by 3, but that isn't. So this is automatically not an answer. Well, that can't be, B can't be an answer either because 3 is also a factor of 6 times 150. So that can't be an answer. Well, C. What about C? 3 is a factor of 150, and 3 is still not a factor of 2 to the 3rd times 5 to the 3rd. So C isn't an option either. What do you have left? What you have left is answer D. And I didn't even have to calculate the prime factorization, and I didn't even have to multiply this out to know that it would be equal to that, because it's very obvious through process of elimination that that's the only answer that you have left. Okay guys, thank you for watching. That is the end of today's lesson. As I said, this is only one type of problem that you're going to see on the MML. If I had to rate the difficulty of the type of problem I just taught you, it would be about medium. There are some problems that are a lot easier, and there are also some problem types that are a lot harder. So we started right in the middle. I hope to see you guys again soon for my next video. So thank you very much, and I hope that you will contact me at 2022.akatyal@jburrows.org. If you have any questions, comments, concerns, complaints, queries, anything, I'm pretty much always available. Okay, thank you guys, bye!